Hi, so welcome to the first lecture video in differential equations, and today we're going to have an introduction of the differential equations. Now, just a little bit of review. Before you go to differential equations, you must already have an idea how to do how to do the derivatives or differential in the differential calculus and integral calculus, and also some basics of the algebra. So I know it's been a year since we had the pandemic, and I'm not expecting a lot. I'm not really expecting that you know a lot of those stuff. Okay, so I'm going to be a lot slow. Okay, for this one. So for this lecture, you're going to learn the following. So you're going to learn what are differential equations and what are the solution to the differential equation. So there are two solutions. So we have the general solution and a particular solution. So I'm going to discuss to you what are those. Okay. And they're also going to learn how to state the type of the differential equation. If that's what kind of differential equation is that, and what's the order and what's the degree. And also you're going to learn how to do the elimination of the constancy and solutions to differential equations. Okay, so today for the first one, we're going to learn what are differential equations and solutions to the differential equations. So for this one, a good example of this one is okay. So So this is an example of a differential equation. Now, what are the parts of a differential equation? We have so we have three. So we have the what we call the dependent variable, and we have the independent variable, and we have what we call parameters. We have the parameters. So yeah. So we have the
Wait lang po. May 2 minutes pa ako.
independent variable, dependent variable, and this yung x is the independent variable, at ito r yung j at yung c at yung omega, and then yung t. Okay, so this is what we call parameters. So we have the dependent variable, we have independent variable, and we have the parameters. Okay. So these are the parts of the differential equation. Now, what is a solution to the differential equation? So we have a general solution and a particular solution. So I will put a note here. So the solution to the DE means that the equation is free from any derivatives. Now, what you see, okay, just a bit of review. When we see anything that's a prime, this means it's a derivative. Okay, so because this is the outcome of a differential. On the other hand, when you see plus c, or c rather, you already know you already have an idea that something or an equation undergone a integration. So if you remember integral, let's say integral of x dx, so that is equivalent to 1 over n x n minus plus 1 plus c. So that's basically, for example, this one is going to be 1 half x squared plus c. So you remember this in integral calculus. So there is plus c. Now, the solution to the DE means the equation is free of any derivative. So it means there is no derivatives or prime. Okay? So how about a particular solution? The particular solution contains no arbitrary constant c. So what it means is when you see an equation, ang topic ay DE, there is no c. However, when we say general solution, it has at least one c. Okay? So what are the examples? So let's give an example. So that's we're going to determine what kind of DE or according to type, order, and degree. So let's try. For example, dy over dx is equals to sine x. We also have d squared y over dx squared plus dy dx minus 2y is equals to 0, and let's say this is 1, it's 2, 3. Let's say we have x squared, we have x squared y d squared y dx squared raised to 5 plus dy over dx plus 2 0. What else? We have 4
Tama ito mga sagot mo?
Okay, so let's try to analyze each one of them. So for this one, number 1, we have dy over dx is equals to sine x. So if you're going to rewrite this one, remember that dy over dx is also equivalent to y prime. Okay, and if you see dy squared over dx squared, that's basically if you see d squared y over dx squared, that is equivalent to y double prime. If you can see 2, you have 2 prime, you have basically 1 exponent here, you see 1 exponent or 1 prime there. So that's all you need to remember. So type, okay, so when you see type, okay, look for the number of independent variables. So if you go back to the previous slides, the independent variable is the letter below. So we can see here that the independent variable that we have is only x. It's only x. This is not part of it. So you're only going to look at this one. So we only have 1 here, which is x. So for this one, we only have also 1, which is yung x. So this is, so what kind of this? So there are 2 types. So we have ordinary, we have ordinary differential equation, and we have partial differential equation. Now, sir, what's the difference? Now, the ordinary differential equation only has one independent variable, while the partial DE has two or more independent variable. Okay, so for this one, number one, you only have one. So basically, this is an ordinary differential equation. How about for the order? Now, for the order, the tip here is look at the highest order derivative. Now, the highest order derivative is how many prime that you see. So, you're going to select or you're going to look at the highest number of prime. So, as for this problem, or as this equation, differential equation, you only see one. So, you only see one. So, this is order of 1. Of 1, okay? Now, for the degree, look at the exponent of the highest order derivative. Now, if you're going to put your attention in this one, you only see, you see nothing aside from 1. So, this is an ordinary differential equation, order of 1, degree of 1. Okay? How about for number 2? Okay, now, what the type? Going back here, we only see x. So, obviously, this is going to be still the same, ODE, or ordinary differential equation. Now, how about for the order? Now, the order, again, is looking at the highest order. So, if you're going to look at this one, remember that d squared y over dx squared is equals to y double prime. So, in this one, you can say that it's y double prime plus y prime minus 2y is equals to 0. Okay? So, looking at the highest order derivative, we have 2. So, this is order of 2. How about for the degree? Now, we see that there is no exponent or power for this one, so we only have degree of 1. Okay? Okay, so number 3. So, we see here that this is a lot more complex. Now, what is this? So, looking at the independent variable, we only still have 1, so x. So, this is an ODE. As for the order, again, looking at the highest order derivative. So, we have d squared y over dx squared. So, between these two, you only have degree order of 2. Of 2, because we see y double prime, right? Okay? How about for the degree? Again, degree, look at the exponent of the highest order derivative, and we see there is 5. So, this is degree of 5. Okay, for number 4, this is called, partial. Automatically speaking, this is partial. Whenever you see this kind of, iba kasi yan ito kasi yan ganyan. Hindi siya yung D na D. Okay? Hindi. This is somewhat like this. So, this one and this one is not the same. They're different. So, when you see this one, okay, so looking at the independent variable, we see that we have partial of y and we have partial of z. So, we have 2. So, this is already a partial differential equation. What's the order? We only see 1. Order of 1, degree of 1. Okay, for last item, we have d cube y. So if we're going to rewrite this one, we see y triple prime squared minus x y double prime cube plus x cube is equals to 0. Actually, this is the technique para hindi ka malito. Now, again, what type of D is this one? So this is you only see 1 independent variable. So obviously this is going to be an ODE. So how many degree? So what is the order? Sorry, the order of this one is the highest order derivative, and that's 3. This is not it. Okay, even if you see 3 here, that's not the order, that's the degree. Okay, so this is the highest order, so this is degree order of 3. How about for the degree? So the degree of this third white triple prime is 2. So degree of 2. Okay, so I hope that clears that. Okay, so now we're done with the overview of what are the parts of the differential equation. So you already know what the solution to the DE is. But by the way, our particular solution. Now let me give you an example of a particular solution. Now what I've already given you a while ago is an example of a DE. So DE, example ng DE, yung kanina, D squared. So that's basically y double prime plus y prime is equals to 3. Okay, so this is a differential equation. As for the particular solution, what's an example of a particular solution? So it says here contains no arbitrary constants. So looking at this one, so a particular solution is this one, 2x y plus y squared minus 2 is equals to 0. Now, sir, paano nangyari yun? Paano nangyari yun, sir? This means that this means that the particular solution has already been yung C or yung arbitrary constant ay nakuha nyo na or na-solve nyo na yung arbitrary constant C. This means that this can be the arbitrary constant, probably, okay? So, how about for the general solution? The general solution looks like this. So, 2xy plus y squared plus c is equals to 0. So, as you can see, this is a general solution. When we say general solution, it means that the value of c can vary. So, it's not exact. It's not particular. Kaya nga sinabing, kaya meron tayong particular eh. When we say particular, it means that we already know the value of c. As for the general solution, it is basically a formula. You don't know the value of c. So that's the difference. Okay, so you already know that one, and how to spot the type of DE, how to get the order of the DE and the degree of the DE. So let's try to do the elimination of constant. So may book dito. Elimination of constant. Okay, so example. Let's say y. Sorry, may calculate. Let's say y is equals to 3c1 e raised to negative 2x plus 5 c2 e raised to 3x. So let's say that's an example. Okay, so now what is this? So what we're seeing is a solution. Okay, a solution to the DE. Now, does this equation contains any derivatives? No. You don't see any derivatives in this equation. That is why this is a solution to the DE. Now, if you eliminate the constant c, you will get the differential equation itself. So that's what we're going to do. We're going to eliminate c in order for us to get the value, in order for us to obtain the differential equation. Okay? So, if you can remember your integral calculus, let's say going back to integral of x dx, okay, so this is 1/2 x squared plus c, okay, so it means that you integrated x once, so you see plus c, okay, so because you integrated the function once, so you have only 1c. Now the question is, sir, if you integrate an equation twice, will you get 2c? Well, yes. You get c1 and c2. You will get c1 and c2. So for this one, you see that we have, okay, so you see we have c1 and we have c2 here. It means that this equation should be integrated, should be differentiate. Okay. Sorry. Now, when we see something which has c, it means that nag-integrate tayo. Now, the opposite of or the counter of integral is the differential or derivatives. Now, since that we already know na nag-integrate tayo kaya tayo merong c, babalik natin yung sa dati kaya tayo magdi-differentiate. Now, if you're going to differentiate this this equation, okay, we're going to differentiate with respect to x. Okay, you're going to differentiate with respect to x. Now, y. As you can see again, dy over dx here, the independent variable is x, and the dependent variable is y. So what this means is the value or the function of y is dependent on the x. What? Because it's dependent, kaya nga dependent siya. This is the dependent one and this is the independent one. So it means, for example, okay, practice lang. If you're going to differentiate, let's say x, y, okay, squared, cube. If you're going to differentiate this function with respect to x, okay, with respect to x, it means that y will be like a dummy or a constant. So it means that you're only going to notice x squared because you say it differentiate with respect to x. So x lang ang papansinin mo. So you have 2x y cubed. Okay? How about when we say, sir, x squared y cubed differentiate with respect to y. Now, when you say differentiate with respect to y, ang papansin nyo lang ay yung y cubed, leaving x squared as a constant. So you will have 3x squared y squared. So that is if you're going to differentiate the function with respect to y. Now, going back here, alright. So, differentiate with respect to x here because we are talking about dy over dx. So, hope that's clear now. So, what this means is you're not going to really interpret it. And you're not going to look at it this way, but always remember that if you're going to differentiate this one, the result is y prime equals to again, ang papansinin nyo lang ay itong may x. So the derivative of e, okay, if you can remember, the derivative of e raised to u is u e raised to u. Okay. So here, this one, the derivative of this one is e raised to 2x. So the derivative of e raised to negative 2x. This is negative 2. Sorry. So this one. Oh, sorry. Pangit na example ko. So, dito tayo gagamit ng u. Gagamit tayo ng a. Gagamit tayo ng a. So, okay. So, e raised to ax. Okay. So, that's a e raised to ax. So, ito yung differential niya. So, we have 3 3. So multiplied by 2x, and we have, alright, okay, going back. So where are we? Okay, so 3c1. Okay, so derivative nito is 3c1 e raised to negative 2x plus 5 3c2 e raised to 3x. Okay, so ayusin natin. Y prime is gonna be negative 6 c1, okay, c1 e raised to negative 2x plus 15 c2 e raised to 3x. Now we have two constants, so uh, we're going to differentiate this term twice. So we have prime, so again we're going to differentiate again. So we basically, sorry, okay, so differentiate again, okay, with respect to x again. So we have y double prime is equals to, again, so it's gonna be negative 6 times negative 2 c1 e raised to negative 2x plus 15 times 3 c2 e raised to 3x. So simplify. So y double prime is equals to negative 6 times 2, we have positive 12 c1 e raised to negative 2x. So 15 times 3, 45. So plus 45 c2 e raised to 3x. Now, this is difficult because the goal here is to eliminate the value of c, which means that you are going to find ways in order for you to remove that c. Okay, now we have to bura natin to. So this is actually the reason why medyo mahaba talaga ang differential equation. So sinasabi nila, probably narinig nyo na hirap ng DE, ganun, kasi ang haba-haba, kaya punuin ng isang blackboard, isang problem, mga ganun. Kasi totoo naman talaga. However, nagiging nangyayari lang yung kapag ang differential equation mo is too complex or napakaraming value ng C. Kasi kung mapapansin nyo, kapag marami kayong value ng C, let's say C5 or C10, naabot na kayo ng maraming beses nyo gagawin yun na ulit-ulit. So it's gonna be 10 times kapag C10. Okay? So going back. So we have equation 1, we have equation 2, and we have equation 3. And our goal is to eliminate C1 and C2 in each of the equation. Now, may technique which is yung matrix style. So all you need to do is to rewrite this again. So y, and then all you need to do is equate all of this. Okay. First step is to equate all of them to 0. So you have y minus 3 c1 e negative 2x minus 5 c2 e raised 3x is equals to 0. Write this also, y prime plus 6 c1 e raised to negative 2x minus 15 c2 e raised to 3x is equals to 0. And also last one, this is the y double prime is gonna be negative 12 c1 e raised to negative 2x minus 45 c2 e raised to 3x is equals to 0. Now, so you're going to put this into matrix form. Now, the matrix form goes like this. So all you need to remember, okay, all you need to remember is Yan. You're only going to remember the parameter. Oh, sorry. You're only going to remember the parameters. No, not the parameter, sorry. Itong mga to, I don't know the name for this one, but here they are. Sorry. Okay. Change the color, so we put dark blue. Okay. Alright, so we write this one. We rewrite this way. So y minus 3. Bakit di ako salat dito? So magiging y, sorry, y minus 3 minus 5. We have y prime plus 6 minus 15. We have y double prime minus 12 minus 45. Okay, so may technique. Okay, technique na tinuro ni Engineer Bam. So you do this one, you do this line and this one and this one. Okay, so ano gagawin? All you need to do is to multiply. So magiging y times 6 minus 45. Okay, so it's going to be y multiplied by 6 multiplied by negative 45. Okay, next is so ito muna and followed by this one. So pero ang kasunod niyan, okay, so this one, okay, so this one and this one. So you have y double prime multiplied by negative 3 multiplied by negative 15 and this one you have y prime minus 12 and then this last one minus 5, and then you're going to add them. So but syempre sasunod yun sa sign. Okay, so 6 times negative 25 so we have negative 270. So we have dito ko lang susulat sa baba. So we have negative 270 y. Okay, so ito naman. So we have negative 3 times negative 15. So we have 45 positive. So plus 45 y double prime. Okay, so negative 12 times negative 5. We have 60 positive 60 y prime. Okay, equals to 0. Now we're going to rewrite this one ascending order, descending order. So it's gonna be 45 y double prime plus 60 y prime minus 270 y is equals to 0. Now this is the differential equation. Pero syempre kaya pa i-simplify yan. So let's try 270 divided by 45. Okay, so pwede tayo simplify. So divide by, di pala pwede i-divide ng 45. So let's try 30. No, hindi rin. Okay. So wag na, yan lang muna. So this is the differential equation. DE. Yay! So the differential equation contains derivatives, and y double prime, y prime are the derivatives. Okay, so that's it. Now you might be wondering, sir, what if we 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 turn DE back to its solution. Okay, now that's for the now that is going to be the next topics. So we're going to, okay, this particular topic ay ganda sulatan to. Okay. Sorry. Now, ito na yung topic na ito. So these are the topic, or this gonna be the next topic for the week. So you're going to learn how to how to determine the solutions of the how to get the solutions when you were given the differential equation. So una, differential equation muna, and you're going to find the solution. Okay? So the question is how. Now, I'm going to give you the, I'm going to immediately give you the overview. Okay. Going to give you immediately the overview. Now, okay. So solutions to the differential equations, we have, okay, we have many techniques. So we have number one, which is the first thing that you're going to learn is what we call separable differential equation. Then after learning how to do the separable differential equation, you're going to learn the homogeneous differential equation. 3, you're going to learn exact DE, and 4, non-exact DE. Okay, what else? What else you're going to learn? Okay, so you're also going to learn linear and linear DE and Bernoulli. Bernoulli's equation type. Now, separable DE, homogeneous DE, exact, non-exact, linear, and Bernoulli's are can be used when you are dealing with first order DE. First order DE. Now, when we say first order differential equation again, these are the differential equations that has first order DE. Yes, these are the differential equations with only one. Okay, so puro y prime lang yan. Puro y prime lang. So, there will be a different topic when we talk about higher differential equations. Okay, so I don't know if I given it in the I don't know if I mentioned it in the GC if we're going to talk about higher differential equations. Okay, siguro pag may time dadaanan natin. So let's say x1 sorry, let's say x topic, yun yung higher order DE. So when we say higher order DE, so 2 and above. So magiging y double prime. Okay? Now, going back to the first example that we have here, the differential equation that we obtained from this solution has an order of 2. This means to say that this is already an higher differential equation or higher order differential equation, and that's the reason why we cannot immediately go to the higher we cannot immediately go to the higher order differential equation. I'm going to teach you first the first order differential equation, or simply FODE. And the techniques for the FODE are the following: separable, homogeneous, exact, non-exact, linear, Bernoulli's equation. Now, I don't have to worry about the complexity. When I say complexity, sir, mahirap po ba? Okay. When I say, so the reality is, magiging mahirap ang DE. Okay? Mahirap ang DE kapag hindi maganda ang foundation mo sa algebra and sa differential calculus and integral calculus. However, since this is already an online class and hindi naman masyadong stricto pagdating sa math ngayon, what I suggest is that you print out, or you're going to always put at your side the differentiation and integration formulas, because you will always need this. And you remember all the differential and integration techniques. Okay, so differential techniques, you have chain rule. So integration techniques, always remember the partial integration, partial fractions integration, and also remember the algebraic and trigonometric substitution, and also remember what we call IBP, okay? Integration by parts. Kasi mas madalas yung gamitin ito. So, integration by parts. So, what basically you're going to do is you're going to combine your skill in differential calculus and integral calculus. So, yun lang naman. So, again, going back to the question, sir, madali po ba? Yes, madali lang. Madali lang ang DE. Madali lang siya. Why? Why? Why madali? Because the formula or the tricks how to solve for the differential equation follows an algorithm. When I say algorithm, meron siyang process, okay, or series of steps. Merong series of steps. So, step 1, step 2, step 3, step 4. That's applicable to all of this. Okay? So, yun yung reason kung bakit madali ang DE. Meron siyang process or series of techniques. And all you need to do is to familiarize yourself or to learn yourself how to follow the process or the series of steps. Okay, so I guess that's it for this first video. And for the next video, we're going to solve or going to learn how to do the separable differential equation.